Hi everybody. I'm going to do a quick video on solving equations using our DCMCS method, just so that those of you who may have missed class last week or maybe just need a little more work with it can review this and hopefully get some practice in over the weekend. Okay, so as I said, DCMCS is a little something that I came up with to help us remember the steps that we're going to use anytime we need to solve an equation, specifically a linear equation, which means that it has x's in it. It shouldn't have things like x squared or x cubed or anything like that. We're only going to be working right now with equations that just have an x in them. And if you have that, you can use DCMCS to get the variable by itself, or to find the solution, to find the answer. Okay, so some equations are more complicated than others, but DCMCS will get you through the process, whether you have a simple equation or whether you have a super complicated equation. So let's go through what the steps are, and then I'm going to do a few examples with you. Okay, the D stands for distribute. And if you don't remember distribution from middle school, distribution is the thing where there are parentheses, there's a quantity in parentheses, and there's a number out front multiplying. And what the point of distribution is it's to get rid of those stinking parentheses. They're in our way. They act like little walls that we can't get inside when we're trying to do math. So I want to get rid of them in order to solve my equation. So the first thing I'm going to do when I distribute, my goal here is to take this 2 and multiply it. It's sitting next to the parentheses. That means multiply, but the parentheses are telling me something. They're saying, hey, you can't just multiply this 2 by this x. You have to multiply the 2 by everything inside the parentheses. So notice here, the 2 with parentheses x plus 3 turns into two terms, a 2 times x and a 2 times 3, which comes out to 6. And the plus sign that was in the parentheses reappears over here. So all we did was rewrite this. It's not new, it just looks different. So for example, if x was, let's say, 5, if I did 5 plus 3 and got 8 times 2, that would be 16, right? Okay. Over here, if x is 5, 2 times 5 is 10, plus 6 is still 16. So I didn't change its value, I just made it look different. And for us, that's going to be really helpful in solving equations if we have parentheses to get rid of them. So we'll use distribution to do that. Again, we're not changing the value of it, we're just changing the way it looks. We're giving it a little makeover. Okay. The first C stands for combine, and what we really mean when we say combine is combine like terms. And again, like terms are things like x, 2x, 3x, and so on and so forth, or things like 1 and 5 and -6 and 27, right? These terms have numbers in them. We can combine them with addition or subtraction. These don't, they're just numbers. We can combine them with addition or subtraction. But what we can never, ever, ever do is combine an x term with a number term using addition or subtraction. That's not okay. That's why when we say combine, we always say like terms. And what we mean by that is terms with x's are like terms and any numbers are like terms, but never the two shall meet. We're never going to combine a number term with an x term. Okay, so if you look at this little equation that I wrote, and let me erase a little bit so you can see better. Okay, notice I have color-coded my like terms. So I have a 2x here, I have a 3x here. Those are like terms because they both have an x on them. There's another one over here. He's an x, that's why he's red. Now notice, this has a number in front, a 2. This has a number in front, a 3. This guy doesn't have a number in front, and it might look funny to you. If that happens, it's okay to put a 1 in the front. This x just means there's one x. This means there's two x's. This means there's three x's. If it makes you feel better to put the 1 there as a placeholder, go right ahead. Okay. Notice there are other like terms here. Okay. I've got a 6, I've got a -7, and I've got a 1. They are like terms. So when we say combine like terms, what we want is to go into the equation, and every equation has two sides. There's the side on the left, the expression on the left, and there's the side on the right, or the expression on the right. When we combine like terms, we want to stay on each side individually. We never want to cross over that line that is the equal sign. When you're combining like terms, you should never, ever, ever be plucking a term from this side and a term from this side and combining it. So here, on the left-hand side, I'm able to combine the 2x and the 3x because they're like terms. I'm not able to combine anything with the 1 because it's the only number on this side. So I have 2x and 3x. Those two are going to come together to be 5x. And the 1 I can't do anything with, so I'm just going to leave it sit as a 1. Okay. On this side, I have two number terms. I have a 6 and I have a -7. So those two I can combine. 6 and -7 come together to be -1. Then I have this x, but I can't combine it with anything because it's the only x term on this side. So I'm just going to bring it down in the same way over here that I just carried the 1 down. Okay. And again, I said this the other day, but it's really, really important. This line that I drew down the middle is your equal sign. So I'm going to carry down my equal sign. Okay. So if you have parentheses, you distribute to get rid of them. Then we're going to look at the left side of our equation, combine anything we can. Look at the right side, combine anything we can. Okay. The next step is the M, which stands for move. Now, move is based on combine. What I really, 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 really want to do is combine all my x terms and all my number terms. But right now, I have a problem. I can't combine this 5x with this x because they're not on the same side together. I can't combine this +1 and this -1 because they're not on the same side together. So my next step has to be to move some stuff around. The only way I'll be able to combine them is if I move things around. So we move things around using the rules that we talked about yesterday, kind of those basic rules of math, that if you want to get rid of something, or if you want to move it away, you use the opposite operation. So by opposite operation, I mean something like if there's an addition, we're going to do a subtraction. Okay, those two undo each other. If there's a multiply, we're going to do a divide. Those two undo each other. And there are tons of opposite operations in math, but for us right now, those are pretty much going to be the two that we see. Add and subtract, multiply and divide. Okay. So if we want to move something, we're always going to use opposite operation. The other rule, and I'm going to put rule in quotes there because it's my rule, it's not a real rule, is that we always want to move our letters to the left. So those are the two things that I always write down. You want to use opposite operations, and we want to move our letters to the left. Now, opposite operations is a must. This is how you move things, period, end of story, using opposite operations. Letters to the left, that's me. The reason I say letters to the left is because sometimes when kids are solving equations, or adults are solving equations, they kind of can get lost in it. And they start moving things, but they can't remember what they moved or where they should be moving it. Maybe they're not sure what to move or why. So letters to the left, I'm hoping will help you remember what to move and why. So let me rewrite my equation here for a moment. If I have 5x plus 1 on this side, and I have -1 plus x on this side. If I want to move my letters to the left, that means that anything that has a letter in it, specifically in this equation, it's an x. Anything that has a letter in it, so this term and this term, I want it to be on the left side of the equation. That's what I want. Okay. That way I'll be able to make sure that I have all my letters on one side, and then once they're on one side, I can combine them. This next step is combine. I also have some numbers, right? I have a +1 over here, and I have a -1 over here. Those are not letters, so I do not want them on the left. So we're going to look at these terms one at a time and make a choice. Is that term where it belongs, or does that term need to move? Okay. So let's look at our first term. It's a 5x. I want letters to the left. It's a 5x. It has an x in it. It's on the letter side. It's already on the left. I'm going to put a little check mark and leave it there. He's already where he belongs. Next term is this +1. He is not a letter. He is a number. Numbers do not belong over here. This is the letter side. So to this +1, we say, sorry, buddy, you got to move. You can't be here. Okay? So to move him, I'm going to go back to my opposite operations. He's a +1. All we're going to do is do a -1. Now, why do I do that? Because look what happens. +1, -1, see you later. Poof. He just like disappears from that side, right? Which is great news because I didn't want him there. But you have to remember, we have a balance here. There's an equation. So whatever we do to one side, we have to do to the other. So if I did a -1 on this side, I'm going to come over here and I'm going to do it under my number because I'm dealing with numbers, and I'm going to put a -1 on this side. When I do that, -1 and -1 are going to combine to be a -2. So now that I've done a move and also a combine, let's see what my equation looks like. I have a 5x over here still. I have a -2, and I still have a +x. So let's look at our equation again, one at a time. Is this 5x where it needs to be? Yep. Is this -2 where it needs to be? It's a number, and it's over on the right-hand side. Yep. Is this x where it needs to be? No. This x is a letter. It should be on the left. So again, in order to move it, we're going to go opposite operation. That x is being added. We're going to subtract it. So I'm going to do a -x on this side so that it will go away. But I can't just do it on one side. I have to balance that and do it on the other side as well. So now that I've done my move, I'm going to do my combine. So I have 5x minus an x leaves me with 4x. And then over here, these x's are gone. I'm left with a -2. Now, this equation made me do 2 moves. Other equations, you might have to do more than 2 moves. But I will say this, if you do all the combining that you can do in the beginning, you really shouldn't have to make more than 2 moves. Now, some people don't do their combining. They move things one at a time, and that's okay. But if you want to minimize the number of moves you have to make, then make sure when you're on this second step that you do as much combining as you can. Do all the combining you can on the left, do all the combining you can on the right. If you do that, you shouldn't have to make more than 2 moves. After you've made your moves, every single time you're going to come down to the same type of equation. Notice on the left, because I made the choice to take letters to the left, I'm down to one single term, and it's a term with an x in it. On the right, I'm also down to one single term, but notice it's a term. Notice that my highlighter isn't working. All right. I think we got a little bit of, oh my goodness, now everybody's seeing how awful I am at doing technology. I don't know what to do. What happened? Okay, that happened. Okay. All right. That was a fun little detour. Okay, so I have on the left, I have one term that only has x in it. On the right, I have one term that only is a number. So all my x's are over here combined, all my numbers are over here combined. Once that happens for you, the last step is always to solve. And this solve is going to happen the same way every time. It's going to happen by dividing, if my pen will work. Okay. It's going to happen by dividing by the number that's in front of the x, or the coefficient on x. So if you look at this equation over here, I have 4 times x equals -2. The 4 is the coefficient on x. My ultimate goal here is to get x by itself. The way that we do that is by getting this number out of here. This 4 is multiplying. Remember from up here, we said that the opposite of multiplication is division. So if I want to get rid of that 4 that's multiplying, I'm going to divide 4. Now, I would never, ever, ever just do something on one side and not the other. So I'm going to come to the other side, and I'm also going to divide by 4. As soon as my pen catches up to me, there we go. All right, so again, the times 4 and the divide 4 over here are going to cancel out, just like the +1 and -1 canceled out up here. So all we'll be left with is an x. On the other side, all you have to do is divide out, that didn't come up like a 4, is divide these numbers out. And you can go to a calculator to do that. If you go to your calculator and type -2 divided by 4, it's going to tell you -0.5. If you choose to look at that as a fraction, you might reduce that fraction and get -1/2. Guess what? Both answers are right. It's just 2 different ways of saying the same thing. Okay, so that's just a little path through DCMCS, one example of how we follow the steps through DCMCS. If you sit tight, I'm going to give you, we'll walk through a couple examples of how you actually do it when you're given an equation. Okay, here's my first equation. This is a pretty simple one. Notice it didn't start with any distributions at all. So there's nothing to combine or anything terribly difficult. The first thing that I always do is put a seesaw. I put my equation on a seesaw. Some people call it a balance beam or a scale, whatever makes you feel happy. The idea is this little triangle, this little pivot point is sitting right here on the equal sign. Right now my equation is balanced. I need to make sure I keep it balanced. So I'm going to take my pen and I'm going to draw a straight line down. That straight line is going to help me keep track of that equal sign. I don't ever want to lose my equal sign. So let's go through the steps of DCMCS. The first step is distribute. So we say to ourselves, okay, for distribution, are there any parentheses? Are there any distributions that need to happen? When I look at this equation, I don't see any parentheses. Since I don't see any parentheses, my distribution step is done already. It's done for me. Okay. The next step is combine. So again, this is actually 2 combinations. We're going to look at the left-hand side and see if we have any combinations. We're going to look at the right-hand side and see if we have any combinations. On the left, I have a term that has a t in it, and I have a number. I cannot combine those. They're not like terms. On the right, I have just a number, nothing to combine. So my second step is kind of already done for me too in this case. I have nothing to combine on this side, I have nothing to combine on this side. So the first real step that we're going to do is going to be this move step. So here's where we make our choices. This is where people tend to get stuck, but not you. Remember, we want letters on the left, which means we're going to bring any numbers over here to the right. Okay, so this first term, it has a letter in it. Good. Stay put. You're a letter, you're already on the left, good to go. This second term, this is a +12. This is a number term. It doesn't belong here. It's on the letter side and it shouldn't be. So this 12 needs to move. We got to move him. He needs to go to the other side. Okay, so let's move him. It's a plus, so we're going to do the opposite of that, which is minus. We're going to do a minus 12. Again, notice how I write it directly below the 12. And then when I come to the other side, I'm going to write my minus 12 directly below the other number. I'm doing that because those are the things I'm going to end up combining. So on the left-hand side, I have a plus 12 and a minus 12, so those are going to cancel out to a 0. And all I'm left with over here is this 4t, which I'm happy about because it's a letter and it should be on the left-hand side. On the other side, I have a 56 minus 12, and that's going to leave me with a 44. And again, if you can't do that in your head, fine, pick up a calculator. There's no shame in calculator game, in my opinion anyway. Okay, so look what we've got. We did our move step. We did our combine. We're good to go. We're down to this solve step, and look what we have. We have one term on the left that is all of our variables combined together, or all of our letters combined together. We have one term on the right that's all of our numbers combined together. So all we have to do to solve it, all we have to do to finish this out is do a division. The number that's in front of the variable is multiplying, and so we are gonna divide it. So on the left-hand side, my times 4 and minus 4 will cancel and leave me just with a t. On the right-hand side, I have 44 divided by 4, which leaves me with an 11. You know you're done because on the left, you have just a letter, just your variable with nothing else around it. Nothing multiplying it, nothing dividing it, nothing adding or subtracting it. You're down to just a letter over here, and you're down to just a number over here. Now you know you're all set. You've got your solution. So we can call this your solution. Some people want to call it your answer. I don't care what you call it, if that's the solution or the answer to your equation. Okay, let's look at one that has another step added to it. And again, we're going to see if we can follow these steps through. First thing I'm going to do is throw this thing on a seesaw. I need to keep it balanced. I want to make sure that whatever I do to the left, I do to the right side. So I'm going to drop my line so I don't ever lose my equal sign. All right. First step, distribution. So I'm going over to my equation and I'm looking for parentheses. This time, unlike last time, I do see a set of parentheses. So I know I have a distribution to do. So this 2 is sitting out front of these parentheses. I'm going to take it and I'm going to distribute it through those parentheses. So I'm going to do 2 times x, which is 2x. I'm going to do 2 times 3, which is 6. And I'm going to bring this plus sign that was there right on down in between them. So there's my distribution. It's all done. Now notice something. Now that my distribution is done, this looks a heck of a lot like the last equation we solved. Right? So it had a little extra step to it, but once you do the distribution, it looks just like the last one we solved. So every step that we do is going to make them a little bit simpler. So let's see, can we do any combinations here? On the left-hand side of the equation, I have a 2x and I have a 6. I have a letter, I have a number. Can't combine them. On the right-hand side of the equation, all I have is a 15. Nothing to combine, no questions asked. All right, next, move. Who needs to move it? Move it. Let's take a look. Again, letters, you are going to come to the left. Numbers, you are going to come to the right. It's like a middle school dance, right? No? Okay, good. No one laughs at my jokes in class, so I figured no one would laugh at them in this empty room either. Okay, so 2x is a letter, right? We're going to leave him here on the left. He's in good shape. He's where he needs to be. This 6 is not a letter. He's going to need to move. This 15 is not a letter, and I'm actually happy. He's a number. He's already on the number side where we want him to be. So I only need to make one move here, and then I'll be at my last step. Okay, the only move I need to make is this 6. I got to get rid of this plus 6. How do I get rid of a plus 6? I do the exact opposite of plus, which is minus. I'm going to do minus 6 on this side and a minus 6 on this side. Once I do that, it's just a matter of combining my plus 6 and my minus 6. See ya later. I'm down to a 2x. It's the only thing that's left on this side. Over here, I have a 15 minus 6, and I'm going to count on my fingers so I don't mess up. 15 minus 6, I think that's 9. Okay, look where I'm at. Boom, solve step. One term that only has an x in it, one x term, one number term, and they're on opposite sides of the equal sign. So I'm going to do the same thing every stinking time. I'm going to do a division. And the thing I divide by is going to be this number that's sitting in front of x. So I'm going to divide by 2. Whew. Times 2 divided by 2. See you later. Leaves me with my x. Over here, I'm going to divide by 2 as well. Now, people are going, uh-oh, Miss Britton, something's wrong. Right? 9 doesn't divide 2 evenly. So what? You want to write your equation 9 divided by 2? That's fine. Or, if it makes you feel better, you can go to your calculator, divide it out, and get a decimal. It's 4.5. Truth, there's nothing wrong with this, and in the end, we actually prefer it. It's more accurate. If you write 4.5, I don't know if this was a rounded answer or if that was your exact answer. If you write 9 over 2, I know exactly what you got. Okay? So it doesn't actually matter. We're not launching rockets here. Whichever one makes you feel more comfortable. Some people are made uncomfortable by fractions and it makes them feel better to divide it out. Go for it if it makes you happy. Okay. Let's do one more. This one's probably going to be a little uglier if I know me. Oh, of course. Okay, Britton. All right, well, let's start out. I'm not afraid of this equation because I have the power of... It's been a long day. I wrote my own acronym wrong. Okay. DCMCS. I said DCMCS. All right. Let's get this thing on a seesaw. That's a big seesaw. I don't care. I'm not afraid. I'm going to follow DCMCS. I'm going to drop a big old line. Oh, no, I'm not. I'm going to drop a big old line down here. Oh, my goodness. As soon as I get sassy, that's when my life falls apart. I'm going to try this for the third time. I'm going to drop a big old line down the middle here. There's my equal sign. I'm going to drop it all the way down so I don't lose my equal sign. My equal sign could easily get lost in this big fat equation. Okay, let's get over here and start following our steps. I don't care how big and scary this thing looks. We're going to get through it. First step, distribution. I'm looking for parentheses. You see any parentheses? Let me look. Oh, yeah. Here's a pair of parentheses right here, right? Let's get rid of them. I'm going to take this 4 and I'm going to distribute. So I'm going to do 4 times x, which is just 4x. I'm going to do 4 times 5, which is 20. The sign that I bring down is going to be the sign that was already there, the minus. Notice this side of the equation also has a plus 6 sitting there, so we'll bring it on down. Okay. Don't be afraid to write too much. It's better to write too much than not enough. It's easy to get lost if you start trying to do steps in your head. Okay, so there's my distribution. Now, oh my goodness. I know I'm done with my distribution step because I'm looking at this and I don't see any more parentheses. If I still saw parentheses, I would know I had another distribution to do. But there was only one, so I should be good to go. All right, combine. Next step. Again, we're going to look at the left and look for any combinations. We're going to look at the right and look for combinations. So over here, I have a letter term. I have a minus 20. I have a plus 6. Look at this. 2 numbers. I can combine those, right? Minus 20 and plus 6. So the 4x I have to leave alone. He doesn't have a friend over here. But the minus 20 and the plus 6 I can combine into a minus 14. Okay, there's my equal sign. See, I didn't lose him. Over here, I have a 2x, which is a letter term, and I have a 20, which is a number term. No combining to be done. Can't combine a letter with a number, so we're just going to leave it as it is. Okay, so there's my combine step. Combine on the left, combine on the right. Oh my. Okay, here's my favorite step. This is always the most exciting step. This is this moving step. The I like to move it step. Okay, here we go. 4x is a letter term. Is he where he belongs? Heck yeah, he's on the letter side. He's on the letter bench. Good for him. Okay. Negative 14. You are not a letter. You are a number. You got to go. Okay, so how are we going to move a negative 14? With an opposite operation. And instead of negative or minus 14, I'm going to do a plus 14. Now, there is no way I'm adding 14 to this side without also adding 14 to this side. And let me repeat what I said before. Where am I going to write my plus 14? I want to make a wise choice here. I'm going to write it under the 20 because the 20 is what I'm going to combine it with because the 20 is the other number. So think before you write that 14. I don't want to write it under the 2x because I'm not going to combine it with the 2x. If you write it under the 2x, you might end up adding them. So you don't want to do that. So over here, I got a minus 14 and a plus 14. So exactly what I wanted to happen happens. They cancel out and give me a 0. So the only thing I'm left with over here is a 4x. That's great news. Over here, let's combine our numbers. 20 and 14 is 34. Positive 34. I'm still left with this 2x sitting over here, so we'll just bring it down. So I did one move. Let's keep looking. Are there any other moves that need to be made? Again, 4x is a letter. He's already on the right side of the line. 2x is a letter. He does not belong over here. This is the number side. 2x, I'm sorry to tell you, but you have to go. So, there's no sign in front of the 2. If there's no sign, then it's got to be positive. If they want a term to be negative, they've got to write the negative. So if there's no sign in front of a term, you can go ahead and write a plus there if it makes you happy. So that means that the opposite would be minus. So I'm going to write minus 2x over here. I'm going to write minus 2x over here because I want to keep it balanced. Let's do our combinations. Plus 2x and minus 2x. See you later. The only thing I'm left with over here now is a 34. 4x and minus 2x is going to combine to be a 2x. 4 minus 2 is 2. So I did 2 moves and 2 combines. I did 2 steps where I had to move a term and then combine it. And look where I'm left. I'm left with that beautiful situation that we were after before, where I have one term on the left with an x and one term on the right without an x. So that last step, that solve, is staring at me. All I have to do to finish this off is one little division. This 2 is multiplying the x. I want it out of there, so I'm going to do the opposite of multiplication. I'm going to do division on both sides. So the 2's go away. I'm left with x. And over here, 34 divided by 2. Let me use my calculator. I'm pretty sure that's 17. Okay. And there I have it. Look, a single x with nothing else around it and a number on the other side. I have my solution. Okay. Like I said, DCMCS is going to get you through even the most complicated of equations. It'll get you there every time as long as you follow through the steps. All right? Please make sure you're practicing these in the Quizlet. Try your assignment, and then we will talk to you on Monday. I hope everybody's having a good weekend. Bye.